We're going to be graphing absolute value equations today, and we're going to find out that they look really close to vertex form of parabolas, which is why we're going over it. So our goals today are to be able to graph absolute value equations, and then we also want to be able to recognize similarities between absolute value equations and vertex form. This is also a refresher of absolute value in general, so we'll go over that. So our absolute value review, if you can recall, what does the absolute value mean? And before I go on, go ahead and pause, remind yourself, except for the fact that we have a thing on a poster on here, but pause the video, remind yourself. And now that you've done that, absolute value means the distance away from zero. And so it's going to be a positive number, and just remember that distance is never a negative, and that's because of physicists. You can blame them for that. And absolute value, the way that we write that is we have the two bars. And so we'll have like something in between two bars, and that's saying what is the distance that this thing in between these bars is from zero. So here, let's just go over these really fast. We have the absolute value of -3. Well, we have -3 right here. What's the distance from zero? It's 1, 2, 3. So our distance is 3. And it's the same thing as regular 3. So if we had a regular 3, there's our regular 3, and what's the absolute value, or the distance from zero? Well, it's 1, 2, 3. Same thing is going to happen here with a -7. We don't have it on our number line, but we know that it's just how far away from it is. How far away from zero is it? It's 7. And how far away is 54 from zero? Well, that's 54. So go ahead, do this quick check and evaluate the absolute value. Remember, just do the stuff inside before you take it. It shouldn't be too bad. Now let's go over vertex form really fast. Remember that vertex form gives us the vertex, hence the name. And it's of the form f of x is equal to a times x minus h squared plus k. We can graph it by using the vertex as a guide, as well as a couple of other things, and we're going to look for patterns in the graph. If you haven't already found these patterns, go back to the lesson 3.3 video. We'll go over, it'll talk about that and review vertex form before you start on this. But in general, here is our basic format. We notice that our A is going to be our vertical stretch in our direction. So if A is positive, it's going up. If A is negative, it's going down. H is going to be our X value of the vertex. K is our Y value of the vertex. And from there, we just kind of make things work. But to graph them, what we're going to do is we're going to be given the equation, f of x is equal to a times x minus h squared plus k. You're going to find the vertex, which is going to be hk. Then you're going to build a table around the vertex, aka the axis of symmetry, and use some info like our min and our max and our concavity to graph it. Well, if you look for graphing absolute value equations, you're going to notice it's exactly the same thing. Given the equation, and here's the equation, f of x is equal to a times the absolute value of x minus h. There is no squared up here, it's just x minus h absolute value plus k. A means the same thing, h means the same thing, k means the same thing as it did before. So we're going to find our vertex, and our vertex is going to be h, comma, k. And then we're going to use A to find the next points, kind of like our slope. We know what from A, if it's going to be really thin, or if it's going to be if it's going to be stretched out, or if it's going to be spread out and a lot wider. And we know if it's going to be pointing up, so opening upwards or opening downwards. And from there, we're going to be able to do it. The only difference here is, remember, when a vertex form parabolas are curvy, absolute value is going to be straight lines. So let's graph these. Here we have the function f of x is equal to 2 times the quantity x minus x plus 1 in absolute value plus 4. Well, our vertex is going to be our h comma k. Remember, because this is a negative in our basic formula, it's going to flip our sign, so our vertex is actually -1, 4. So we'll go over 1 and down 4. 2 is going to be our slope for right now. So what we're going to do with this is we're going to go up 2 over 1, up 2 over 1, and we're going to keep going like that. And you notice it's a straight line. as close to straight lines as we can get. And there you have it. That's all that's going to go on. Now, how does this work? Well, we have a little bit of wiggle room in here because we have x plus 1. We're going to be x plus 1 away from 0. And we're going to like add 4 to that number. So if we wanted to get to 0, what we're going to have to do is make this 0 and then subtract that off. So we have some wiggle room. That's why our vertex moves. R2 is just saying that for every step up, we're going to go over, or for every 2 steps up, we go over 1. And from there, we just kind of let it go. It's not too big, nothing too scary, nothing too surprising. And the reason why it's 2 straight lines coming out of here is because this and this are both answers. Both 0 and -2, when you plug them into here, are going to give out a -2 for our y. Let's do another one over here. We have f of x is equal to -3 times the absolute value of x minus 2 minus 3. So our vertex is equal to 2, -3. So we're going to go over 2 and down 3. And our slope, we're going to call it slope. It's not really the slope, it's our vertical stretch, but it's going to work for us, is a -3. So we're going to be pointing downwards. And we're going to go 1, 2, 3 over 1, over 1. And we just draw in our lines. They're straight lines, and that's it. Here's your last quick check. You need to graph each of these absolute value equations. They shouldn't be too bad. And in reality, it's like if you've done this with absolute value, with vertex form parabolas, absolute value equations are really easy because they're just straight lines. And once you've done that and pause the video and like graph these, that's all you have to do for this lesson.